I am Mr. Klein, and I'm about to teach you a little bit of statistics. You should, before you go any further, get out your composition notebook and turn to one of the first couple of pages and write down the title of today's lesson. Anytime I'm writing something on paper in these videos, you need to be writing it down in your composition notebook. Please make sure you have one of these and not something like I have that is perforated where the paper tears out. I would use a composition notebook too, but they don't really jive with my camera here. So I had a bunch of students and they were just chilling in their seats, and I measured their heart rates. And I'm going to make a little dot plot of the data that I gathered. 2 of them had a heart rate of 60. 3 of them had a heart rate of 70. 2 of them had a heart rate of 80. 1 of them had a heart rate of 90. And then 1 of them had a heart rate of 100. By the way, this is in beats per minute. I did the same thing for students that had an active heart rate, which means I had them run around the halls a couple of times. And the results I got this time were a little bit different. 2 of them had a heart rate of 90. 1 of them had a heart rate of 100. 1 had a heart rate of 110. 2 with a heart rate of 120. 1 with 130, and 1 with 140. This is also in beats per minute. These, incidentally, are called dot plots. Now, the goal for today is to talk about measures of central tendency. And the most important word there is central. Central means how do we talk about the center of a data set? And that's why I've drawn you a couple of pictures. When you are looking at a picture, you can visually see where that center should be. So as I'm looking at the first one, it looks to me like the center should be somewhere around there. It looks like it's about 75. And if I looked at the center of these dots over here, it seems like it would be, I don't know, somewhere in this neighborhood right here, somewhere between 110 and 120. Now, that is a very informal way of talking about the center, right? What we need is a specific way to talk about it, and it turns out that we actually have 3 of those. So the first one is called the mean. Okay, and you know that the mean is really the arithmetic average of a data set. Okay. Now, there's a formula that you're going to see me use sometimes, and that formula is going to look like this. First thing I need you to know is that the symbol that pretty much all statisticians use to talk about the mean is an X with a bar over the top, and we have a clever name for it. We call it X bar. And we say that since what you're doing is you're adding up, adding up each one of those values and then dividing by the number of values or observations in the data set, we write it this way. Sigma represents the sum. Xi represents each one of the observations. So this right here would be the sum of observations. And then we need to divide that by the number of observations. And I'm going to write that as 1 over n, where n is what we're going to call the sample size. And listen, I know that you've known how to do the mean for years and years and years, but I'm setting up a lot of stuff that we're going to use all year right here. Specifically, n is always going to represent the sample size. So what this formula says is take each one of the observations. So there was a 60, and then there was a 60, and then there was a 70, plus ellipses, keep going until the last one was 100. So you're going to add all those values up. And then you're going to divide by the number of dots. And if you count up the number of dots, you'll get 9. And this divided by this gives us 75.6 beats per minute. Okay, that was for the people with a resting heart rate. So the mean is the first way that you can calculate a measure of the center, a measure of central tendency. The second way that we look at is what's called the median. Okay. And when we talk about the median, we talk about the middle value. So if we were to take the data and put it in ascending order, meaning from the smallest to the largest, that would look something like this. We had a 60 and a 60 and a 70 and a 70 and a 70. We had two 80s, a 90, and a 100. Now there's 9 values there. So if I'm looking for the middle number, that's an odd number. If there's an odd number of values, like 9, then there will be a middle value, and that middle value ends up being right here. Why? Because if we circle that number, we have 4 observations with a lower heart rate, and we have 4 observations with a faster heart rate, which means that there's a balance on either side that makes this right here the median. Okay? So that's the second way that we can measure the center. The last way that we can measure the center is what's called the mode. And the mode is the most commonly occurring value. So if you look at this list that we've got right here, the number that comes up the most is 70, which happens 1, 2, 3 times. So our mode would be 70. So there's your 3 measures of central tendency. Let's just sort of collect things together, and I'm going to go through some symbols with you here. So for the resting heart rate, I would want you to be able to identify that N, or our sample size, is 9. That is not a measure of central tendency. That X bar is 75.6 beats per minute. That the median is 70 beats per minute. And that the mode was also 70 beats per minute. Let's go through the same thing with the people that have the active heart rate. Now, if I asked you what would you expect for the center of a group of people that have an active heart rate, you'd say, well, when I exercise, it makes my heartbeat go faster. So our measures of center should be larger. Let's look at what we have here. So we have 1, 2, 3, 4, 5, 6, 7, 8. So we have a different sample size this time. So X bar, recall that X bar is the mean. So if I added up a 90, a 90, a 100, a 110, 2 120s, a 130, and a 140, that would give me a number that's larger than the 75 we got here. In fact, it comes out to be 112.5 beats per minute. And then let's also talk about the median. Listen, I wanted to talk about this one with you because there are an even number of values in this data set. And so what you do when there's an even number is a little different than what you do when there's an odd number like there was in the first example. Let me write them down here. So we've got a 90, a 90, a 100, a 110, a 120, a 120, a 130, and a 140. So since this is an even number, I should be able to break it into 2 equal parts. And I can say there's 4 observations here with lower heart rates and 4 observations right here with larger heart rates and no value in the middle. But we still need to talk about the median. And so what we do in this case is we just find the 2 values that are the closest to that middle and we average them. So your median would be 110 plus 120 divided by 2 gives us 115. Coming back up here. Whoop. This would be 115 beats per minute. Last thing we should talk about is the mode. Now, maybe you noticed something about this data set, that there's 2 values here that are 90 and 2 that are 120. So we have 2 different beats per minute or heart rates that have the same number of observations. So which one should you choose for the mode? The answer is you pick both of them. So you can have more than one mode. Our modes would be 90 and 120.